Right, we have this particular integral to evaluate the integral from 0 to pi over 2 of the square root of sine x divided by the square root of sine x plus the square root of cosine x with respect to x dx. Right, we present a solution to this particular problem in a step-by-step fashion as follows. Right, so what we do is we let I be equal to the integral from 0 to pi over 2 of the square root of sine x divided by the square root of sine x plus the square root of cosine x dx. Right, so we let I be this. Now, if I is exactly this, and we proceed to use another property. What is the property? There is a property that we shall use. The property of certain integrals. The integral from a to b of f of x dx is the integral from a to b of f of a plus b minus x dx, like so. So now, this means that if you have the integral I from 0 to pi over 2 of the square root of sine x divided by the square root of sine x plus the square root of cosine x dx. Right, we have already seen from the property that this can be written as the integral from 0 to pi over 2 of the square root of the sine of pi over 2 plus 0 minus x divided by the square root of the sine of pi over 2 plus 0 minus x. We close like this, plus the square root of the cosine of pi over 2 plus 0 minus x dx, like so. Right, we proceed to simplify this, but pi over 2 plus 0 minus x is the same as just pi over 2 minus x, so that this is I holds the integral from 0 to pi over 2 of the square root of the sine of pi over 2 minus x times the square root of the sine of pi over 2 minus x here, plus the square root of the cosine of pi over 2 minus x dx. All right, so that's what we have. Now, the couple of things that we need to note here. So now the pi over 2 minus x is an angle in radians in the first quadrant in which all the trigonometric functions are positive, but the sign changes to cosine x divided by, and this one becomes cosine x, and this one becomes the sine of x dx, like so. Now, the couple of things that remain very important. So we're going to consider the integral, or 2 times the integral, because now we consider the addition of the first integral. So in other words, you can write a trivial step. So 2i, it's going to be out. This is okay. Right, it's going to be exactly the first integral that was given, the sine of x divided by the square root of the sine of x plus the square root of cosine x dx. And then we have the integral from 0 to pi over 2 of the square root of cosine x divided by the square root of sine x plus the square root of cosine x dx. Right, so we're adding the 2 integrals, where the last I is this one here, and the I in the beginning is this one that was given. Okay, let's proceed now. Let us proceed. If you add these two, so you have 2i, which is the integral of 0 to pi over 2, which is sine x plus cosine x, right? So you have the square root of sine x plus the square root of cosine x, the square root of sine x plus the square root of cosine x dx. Right, now we can see that clearly these are equal to each other. The numerator equals the denominator, and therefore the result is 1. So that we have 2i, the integral from 0 to pi over 2 of 1 dx. Right, the integral of this is exactly x, evaluated from 0 to pi over 2. Substitution here, taking the limits of integration, is pi over 2 minus 0, and the result is pi over 2, which means 2i is pi over 2, and which means I is pi over 4, which means I is pi over 4. And this mentioned, we then proceed to then say hence. Hence I, which is the integral from 0 to pi over 2 of the square root of sine x divided by the square root of sine x plus the square root of cosine x with respect to x. This integral here is pi over 4. And this is the result. We've solved this problem step by step. And we are most certainly done with solving this problem step by step. Right, so thanks everybody for joining us. And thank you for watching. And we found the integral now. It is pi over 4 radians. And goodbye to you.